We start with Unit 4, Day 1. We're going to talk about classifying triangles. We've got a pretty vocab-heavy lesson today. The work itself, not too terrible. So let's just get through it. All right. So we're going to start by vocabulary for classifying triangles. There are two ways that we can classify triangles. One is based on its sides, and the other is based on its angles. So this whole box tells us how we classify triangles. Usually when we classify them, we use one of each descriptor. Our classification's based on sides. This first one should look familiar to us. It is equilateral. So a triangle is an equilateral triangle if all three sides are congruent. So we see those congruent tick marks. 3 congruent sides is equilateral. Our next vocab word is isosceles. Yes, you do need to know how to spell isosceles. And it is when 2 of the sides are congruent. We call those the legs. So it has 2 congruent legs. And then the last descriptor for sides is scalene. Scalene is when none of the sides are congruent. So 3 different tick marks to show that all 3 sides are different. Then we have triangles based on angles. Hopefully we've seen the word equiangular. Remember we talked about that when we talked about regular polygons and irregular polygons. So equiangular is one of our options. That's when all 3 angles are the same. We also have a right triangle. That is when we have exactly one 90-degree angle. We literally physically cannot have more than one 90-degree angle in a triangle. It doesn't work. Next is an acute triangle. An acute triangle is when we have all angles less than 90 degrees. And then lastly is an obtuse triangle. It means we have at least one angle more than 90 degrees. We actually can't have more than one. Let's just say 1. Questions on that? So two classifications, you usually use one of each. So you could say, I have an isosceles obtuse triangle, and that would be one name of a triangle. All right, we have a couple more definitions and theorems that we're going to see in this unit, especially in this lesson. These right here might be new for us. In any triangle, we have 3 interior angles. Okay, they are literally just the angles that are inside of my triangle here. They're not necessarily congruent. Sometimes they are. These ones are not. Those are called interior. Now, this next definition is a little bit weird. Exterior angle is when we take one of the sides of my triangles, so like that side right there, and we extend it. When we extend any side of a triangle or any polygon, we get an angle on the outside. That's kind of like in between that side that we made and one of the other sides of our triangle. This is just one example of where an exterior angle could be. Every triangle has like 6 possible exterior angles. So if you think about like maybe I wanted to extend this side right here and get an exterior angle out here, that is a possibility. There's a lot of different exterior angles that we could have. But that exterior angle is just made by extending one side. Then, a little bit weirder, we have what is called a remote interior angle. So if you think about that word remote, if you think about a remote destination, you're going somewhere far away, the remote interior angles to an exterior angle in a triangle are the 2 angles that are the furthest away. So here's my exterior angle, that one in red. The 2 remote interior angles are here and here. They're the two interior angles furthest away. Does that make sense? Okay. One last set of theorems here. This first one, very, very straightforward. It's the triangle angle sum theorem. Do we know what all the angles in a triangle have to add up to? Yes, hopefully. It's 180. 180 is our magic number for triangles. And that's what the triangle angle sum theorem states. It just says, if I have a triangle, I know I can add those three things together to make 180. And then my last theorem that I'm going to learn today is the exterior angle theorem. This goes in hand with these definitions that we just did, and it's a little bit weird, and sometimes we forget it, so maybe this is one that you want to star to remind yourself about. The exterior angle theorem states that if I draw an exterior angle, I'm going to use the same colors that we did before. Here's my exterior angle. Its two remote interior angles added together will be the same angle measurement as the exterior angle. So this says angle D, oops, wrong color. Angle D, which is the exterior angle, equals A plus B, the two remote interiors together. So exterior equals remote interior number 1 plus remote interior number 2. A good theorem, again, one that is overlooked sometimes. So if you're looking for something in a triangle, there's a good chance that you have to use exterior angle theorem. Questions on those definitions or theorems? All right, flip it over. I got some examples we're going to do. Number 1, we're just going to draw. We want to draw a triangle to fit each description. Mark the triangle to show the known information. Letter A, obtuse isosceles. What does those two things tell me? What does obtuse mean? Anybody? What is obtuse? It's on the last page. Casper. One angle is greater than 90 degrees. What does isosceles mean? Obtuse told me about the angles. Isosceles tells me about the sides. How many sides are congruent in an isosceles triangle, Caitlin? 2 legs congruent. So let's draw this. I'm going to draw a triangle that has one big obtuse angle. I'm going to try to draw those legs about the same. And then I'm going to mark that. So the 2 legs are congruent. And let's put an angle measurement in here that's bigger than 90. Let's go with 100. Questions there? Okay, next. What does scalene acute mean? What is scalene? Casper. No sides congruent. What does acute mean? Caitlin. It means all angles are less than 90 degrees. So let's draw another triangle. None of the sides are congruent. All of the angles less than 90 degrees. Let's do something like this. Sure, that works for me. We have to mark that the sides are not the same. So I'm going to put different tick marks on all of them. And I have to mark that these angles are all different. And they have to add up to 180. We can't just be picking random numbers. So let's go with 60. Oops. I'm just making these numbers up. Let's go with 60, 88, and 32. Questions there? Okay, last one. Letter C. Acute equilateral. What does that mean? We already know what acute means. Acute means all the angles are less than 90. What is equilateral? Equilateral means, Casper? Perfect. So let's draw a triangle with 3 of the sides equal. And actually, one of our theorems we'll learn later is that if all of my sides are equal, all of my angles must also be equal, which means if they're all 180, then these all should be 60 degrees. Any questions on that? Okay, let's get into the examples here. Number 2, find the measures of the sides of isosceles triangle KLM with base KL. What does that word isosceles tell me again? Casper? 2 sides, 2 legs are congruent. The other part of an isosceles triangle, the one that's not called a leg, is called a base. So KL here is the base of my triangle, which means the 2 legs are LM and KM. And we know that those 2 legs are going to be congruent. So then I'm really easily able to see what my equation is going to be, hopefully. We're going to set those 2 parts equal to each other and solve for D, which is 25 equals 5D, or 5 equals D. A lot of us messed this up on our exam yesterday, but then we didn't follow through and read the directions. We found our variable. We forgot to plug it back in. So we have to take this 5, plug it back in to find all 3 sides of this triangle. We're going to use good notation here. Segment LM is 12 minus 5, which is 7. KM is congruent to it. It should be the exact same. And then KL is 5 plus 6, or 11. Any questions there? All right, we're cruising through. Find x and the measure of each side of the equilateral triangle ABC if AB equals blah, 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 blah. Okay? What does an equilateral triangle look like? Casper? All sides equal. I recommend you draw this out. So I have triangle A, B, C. All 3 sides are the same, and this is 6x minus 8. I have 7 plus x, and I have 13 minus x. What equation can we set up? There's actually a couple different options, so pick your favorite, but what's our equation? What equation can I set up to solve? All right, so x is 3. We still have to go ahead and plug that back in to find the measures of all of our sides. So AB equals 6 times 3 minus 8, which is 10. All of the other ones should be congruent, so we know that they are also 10. But that's also a good way to check our work if we must. Letter A. Find the values of the variables. What's going to be the easiest one for me to find? This x or this y? Go ahead. And what do we do to find x? So I know that x plus 70 plus 30 equals 180, or x is 80. If x is 80, what is y? Ian? Y? Vertical angles theorem. Perfect. Moving on. Letter B. How am I going to set this one up? Perfect. All three angles have to equal 180. That's a 90 degree. 12x plus 6 equals 90. 12x equals 84. X equals 7. Am I going too fast now? Letter C. What do I do here? Any ideas? Kind of a different diagram. Yeah, Dahlia.
The sum of the remote interior angles equal to the exterior angles.
Perfect. The two remote interior angles have to equal the exterior angle. So that means I'm going to kind of squeeze it in here. X squared equals 65 plus 6x minus 10. Got to do a little bit of simplifying. X squared equals 55 plus 6x. Uh-oh, we're not going to be afraid when we have to factor, right? We're going to move everything to one side. And I'm going to figure out what are the factors of my first term, x squared. Well, it has to be x and x. And then factors of 55 that add up to negative 6. What do we think? Casper.
5 and 11.
Which one's positive? Which one's negative?
Negative 11, positive 9.
Perfect. Set them equal to 0. Figure out our answers. X minus 11 equals 0. X plus 5 equals 0. This is x equals 11. This is x equals negative 5. What should we check? Talking about angle measurements in geometry, so we should always be checking any negative answers that we get, right? So let's just double check. Negative 5 doesn't really matter over here. It's going to get me a positive 25 degrees. That's fine. But if I plug it in over here, 6 times negative 5 minus 10 gets me a negative 40. I cannot have that. So this is extraneous. This is my answer. Have to double check those negative ones. Questions on C? Okay, let's do this one really fast and then I'll let you go. Again, exterior angle theorem states the exterior angle is equal to the two interior angles added together, the two remote interior angles added together, I should say. So this is 4x plus 50. This is 2x equals 50, and x equals 25. All good there? Any questions?